Hello guys, I'm here again. So in this video I am going to talk about 1001, which is a quite interesting number. We know that 11 and 101 are the only numbers that are a power of 10 plus 1 that are prime numbers. 1001 has three distinct factors of 7, 11, and 13. When it comes to multiplying by 1001, if you use any three-digit number and multiply it by 7, 11, and 13, you get the same three-digit number that repeats twice. Like, let's take 116 as an example. Okay, so if I multiply 116 by 7, that's 812. Then I multiply 812 by 11. So I put the 2 at one end there, and 1 plus 2 is 3. 8 plus 1 is 9, so I can put the 8 over there. That makes 8,932, and 8,932 times 13. As I said, if you take this number and multiply it by 1001, it gives you this. You see? Well, that's a special way to multiply by 1001, but you can also take it into a few steps rather than directly multiplying by 1001. You can take it into 3 steps. First, multiply that by 7. Like, first, multiply the three-digit number, a random three-digit number, by 7, and then by 11, and then by 13. Or you can do it any order you like. You can multiply by 13, then by 11, then by 7 to get the 1001st multiple of that particular three-digit number, and that three-digit number will duplicate itself like 116,116. Or just to make it simple, you can write down 116 times 1001 is 116,116. Or if you use any of these prime factors one by one, you'll get to that result. So 1001, okay, I'm going to put this number on top. So we know for a fact that it is 143 times 7, 91 times 11, and 77 times 13. So we know for a fact that 11 and 101 are mathematically the only powers of 10 plus 1 numbers that can be prime numbers, because as the power gets bigger, the power of 10 gets bigger, it happens to involve more and more prime factors. Like, if you take an odd power of 10 and add 1 onto it, you'll get a multiple of 11. You can see even 10,001 is not a prime number. So 10,001 is not a prime number because 10 to the 4 plus 1's prime factorization is this: 73 and 137. So I'm going to take a random 4-digit number and multiply it by 10,001 by taking it to 2 steps. I first multiply that number by 73 and then that number by 137. So that 4-digit number that I take, if I multiply it by 73 and by 137, it will be a duplicate of that 4-digit. It will be like ABCD, like I did with 1001. And with a 3-digit number, I multiply that by 1001, it becomes ABC. So the 4-digit example I'm going to pick is 3,167. But first, let me multiply this number by 73. So suppose this. Okay, so first of all, I just take the 7 of that number. So 3,167 times 7 is 22,169. I multiply that by 10, and I put a 0 in front of that. it becomes 221,690. But 73 is a target number for this, of course. So I add 3,167 times 3 onto that. So if I multiply that by 3, it would be 9,501. So I add 9,501 onto that. And okay, so 0 plus 1 is 1, 9 plus 0 is 9, 6 plus 5 is 11, 1 plus 9 is 10, plus 1 is 11, 2 plus 1 is 3. So the answer becomes 231,191. I'm going to write that down here. If I go on to multiply 231,991 by 137, look. So basically, I'm multiplying this number by 10,001. So if I multiply 231,191 by 137, this is what I am going to get. You see that? You can see this group of 4 numbers that clones up to that, because 10 to the 4th power plus 1 is a multiple of 73 and is also a multiple of 137. These two prime numbers, if you compose them, if you multiply them together, that makes 10,001. Let's say if I were to divide 9,564 by 73. So 1 less than that is a multiple of 73. So if I divide that by 73, it will give me 131 points. How it goes. Yeah, there was barely any space for me to write that, but this is the repeating pattern of 1/73rd. Well, as you can see, any number except for multiples of 73 over 73 do have 8-digit repeating patterns, which is short for a number like 73. It's not one of those cyclic prime numbers like 7, 17, 19, 23, and 29, and etc., where it has the full repeating pattern that has every possible remainder that is from 1 to p minus 1. If you divide any number by any of the prime numbers I just mentioned, you get one cycle consisting of any of the remainders from 1 to p minus 1. Meaning you can get all possible remainders from that cycle, and it will have a certain starting point depending on the remainder. It's not like that for 73, because 73 is a factor of 10 to the 4th power plus 1. So 2/73 does not have the same repeating cycle as 1/73, while 72/73 does. And yeah, it is simple to say that 11 and 101 are the only 2 prime numbers that are 1 greater than a power of 10. If I show you what, let's say we make the power of 10 8. So 10 to the 8 plus 1, you can see here, one of its factors is 17. It is indeed 17 times 5,882,353. Let's pick another factor, like let's say 15. So 10 to the 15 plus 1, well, because it's an odd power of 10, you're going to see 11, but you see besides 7, 11, and 13, you can see a group of factors here, 7 distinct prime factors. 9,091 is quite special, you can tell, because it does have a repeating cycle of 10 digits. It has 909 distinct cycles. I just tried 10 to the 47, and yeah, of course, 11 is one of them, but look, you got another prime number here. Let's try an even power of 10, let's say 74, 10 to the 74 plus 1. You see, because it's an even power, it gives you 101, but it gives you another group of prime numbers, including 149. Alright, well now it's the end of this video. Thank you so much for watching, and stay tuned for tomorrow's Plushables episode.